Dear students, Assalamu alaikum and welcome to the online classes. Uh, Let me share my screen so that we can understand the whole context. So this is the first class that we have after the closure. I hope you people are staying safe at your homes. I will try to upload short videos, 10 to 15 minutes, just covering one topic at a time. So in every week until 24th of December, you should be seeing multiple videos uploaded on Tuesdays. It is your responsibility to watch all these videos and then also post questions related to the video lecture into the forum that I'll be creating at LMS. Few quick things. Uh, I hope by now you have already read this project brief, which is available on our course LMS. The project idea submission link I have created. You people will have to submit your idea here. Remember, the project idea. I mean here, the project idea must be submitted by just one member of the group. In each of the group, there are two members. We have already shared the grouping. So one of the group members should submit idea, not both of you. You will have to decide who will be submitting the idea. The deadline for submission is December 3 and 2 days away from today. When you submit the project idea, you need to upload PDF, which is the project idea document, along with the video that I'm hoping that you'll be recording using Zoom or Skype, whichever you feel most comfortable with. And I'm also expecting that when you're recording video, both of you are having equal share in the video. I mean, 5 minutes to one group member, 5 minutes to other group member. Okay, so let's start with today's lecture. I hope you remember where we left when COVID closure was announced last week. We have revised the courses grading because we are not conducting any mid-exam too. So that has been adjusted in final exam and in course project and assignment and quiz. So this one is the revised course grading. We have already seen this example, training the convnets from scratch using cat versus dog. This actually a kind of classic example we have been using in our class. Then we also understood data augmentation. And we saw that when we are uh, training the model from scratch, it gave us around 73% accuracy on a simple convolutional neural network. When we applied augmentation, the accuracy increased from 73% to 87%. And then when we started using pre-trained convnet, there were two ways of doing it: by using feature engineering and by passing whole each image to whole network, including convo base and the fully connected. This actually gave us an accuracy of 96%, quite an amazing accuracy. With some fine tuning, you can even reach to 97%. We have already seen this all in our previous class. This cipher assignment, I hope you people have already submitted it there. It is a graded assignment. It was due last week. I hope you people have submitted it. Now, now we are starting with the text data and sequences. I mean, so far we have already completed our work on images and video. Now we are focusing our now we are shifting our focus on text data. When you're talking about text data, I mean, document classification is one big thing. You have got document from different fields. Say, for example, for BBC website, there might be documents coming from politics category, from sports category, from entertainment category, uh, from international news category. So when you perform document classification, you want that you should have an automatic classifier which can understand the contents of a document and then classifies that document according to the contents inside the document. I mean, the good thing is when you're talking about politics, then words are very specific to politics. For example, in Pakistani context, when you talk about dharna, when you talk about Imran Khan or Nawaz Sharif or Aziz Zardari, you are probably talking about politics. But when you talk about runs, bat, ball, field, you're talking about sports. So the idea of document classification is to automatically classify document in different class label based on contents of the document. And as I told you earlier, the vocab that we use in different classes is mutually exclusive. I mean, the vocab that you use for uh, sports is very much specific to the sports document. Right. Then we also have topic modeling. I mean, you are given contents and you would like that your system should automatically assign topic to those contents. Time series comparison. I mean, relatedness of two stock or documents. You want to do kind of prediction for future stock prices. You can use it. Sequence to sequence learning. This is actually a kind of translation. If you want to do translation from English to Urdu or vice versa or to any other language, you will be doing sequence to sequence, translation. Sentiment analysis. I mean, one big area. I mean, these days, very hot field. I mean, iPhone, if launches its new version today, it will be having maybe billions of reviews next day. Now, it will be a nightmare if you ask them to process all these feedback, all these reviews manually. So you need some automated system. And text classification, text processing in deep learning have really done an excellent job in figuring out if the review is positive, negative, or neutral. Because if you see iPhone release today, and then you would love to see what people are talking about. Are they positive about iPhone? What is their immediate impression? Are they are negative about your iPhone? So definitely they need a lot of input. So for that reason, you will be doing a sentiment analysis. And then time series prediction. It's again to do weather forecasting. We've already done the class project discussion. I'm skipping this. Working with text, I mean, there are certain steps that you need to follow. Those steps are actually these. You need tokenization and you need vectorization. And one of the vectorization method is one-hot encoding. We call them word embedding. The most basic is one-hot encoding. There are many other, but one-hot encoding is probably the most basic algorithm to convert a word into vector. I've been telling you in previous classes, I mean, neural network, it cannot understand images. It needs image intensity. I mean, it needs numbers in the range of 0 to 1. And when you talk about uh, the text classification, again, you're going to directly inject words into neural network. You need to convert those words into numbers. And converting those words into number is actually the process we call vectorization. Right? And word embedding are actually used to perform vectorization. We'll see how we'll do it. But one basic method is this one-hot encoding. Uh, we also have, see here one example which shows how tokenization is done. I mean, say for example, if we have this, the cat, set, and the mat, it can have tokens. There's the first token, I mean, separated by the space, then cat, then set, then on, then the, and then mat. And then you might represent the with this value, cat with this value, set with this value, on with this value. Don't worry if you do not understand how these values have been estimated. You will understand those when you will be learning word embedding. But for the time being, you can see when we convert a token into vector, each of the token is actually given some number representation. And this number representation is what we will be giving to our neural network. Because neural network says, I don't understand text. I do not understand images. Give me numbers. So in order to convert text into numbers, we will do vectorization. Right. When you are doing vectorization, these things are very helpful. Program and mega words. These are usually to capture the context, because they say that word is known by its company. Uh, the way, you know, a human is known by its friends, the word is also known by its company. For example, when I'm saying that we are playing cricket, and then we say you are playing with my emotion, right? Now here the word playing, when you are playing cricket, playing means you are really in the cricket field, and then you are, you know, playing the game. But when I'm saying you're playing with my emotions, I'm not saying that you are sitting in my mind and, you know, drawing you know, pitch and bowling and batting. I mean, here the playing is different. So no, you know, the word context usually is different. Uh, the word meaning is different when its context is different. I mean, when they say he's my blue eye boy, now that blue eye boy does not mean that his eyes color is blue. I mean, here the blue is having different meaning. But if I'm saying that color of my shirt is blue, there the word blue has got different meaning. There it is referring to the color blue. But when I'm saying he's my blue eye boy, it means that he's my favorite. I mean, here you can see that again the meaning of the word is different. Although the spelling, although the pronunciation is same, but the meaning of the word is different depending on what context it is appearing. So that is the reason why we say that word is known by its company. And the company is usually captured by working with n-gram. Here you can see the example of 2 gram. If we have got the sentence which is the cat sat on the mat. So when this is the sentence, let's see what n-gram will be. I'm opening Word. So the sentence is the cat sat on the mat, right? So the first token will be the second token will be the cat, huh? uh, the cat, and then third will be cat, and then it will be cat sat, then it will be sat, and then, you know, cat sat, and then sat on, and then on, and then on, and then the, and then the mat, and then mat. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 different 2 gram tokens can be generated from this sentence. It is simple. I mean, you will extract all possible combinations of 1 and 2 gram, right? So this is 1 with the, and this is 2, the cat, right? And then, I mean, writing cat and the won't make sense because it is same. The cat and cat the is same. So that is the reason why I'm not considering, changing sequence. Then we come to Kate, and Kate will make with set. Then set will make with on with the with mat, and then mat alone. Right. So these are 11 different 2 gram tokens that can be formulated from this sentence. Similarly, if we say the 3 gram, and in 3 gram, the all tokens of 1 gram, 2 gram, and then the cat set, for example, the 3 gram. So you will do the cat and the cat set, then cat set on, right? So all 1 gram, 2 gram, and 3 gram when you're talking about n gram mega words with 3 gram. So all these combinations will be formulated. Remember, we are doing it because we want to see the company of the word, and company of word can be extracted by defining a window. So in first case, when we say 2 gram, the window is 2, right? And when we say 3 gram, the window is 3. And then this window can be longer just to capture better context of the word, right? One of the simplest encoding mechanism for converting words into numbers is this one hot encoding. In one-hot encoding, we actually associate a unique integer index with every word and then turning that integer index I into a binary vector of size n, that is the size of vocab. So vector is all zero except ith element. Don't 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 feel afraid if you don't understand this definition. It's actually very simple definition. See here, if I have the cat sat on the mat. Now it depends on you whether you consider small the and small t and capital T as same. In our example, we consider them different. So here the word, this word and this word are different because this one starts with capital T and the other one starts with small c. So the unique words in this sentence are 1, 2, 3, 4, 5, and 6. It means that vector size will be 6, right? So vector size will be 6. 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right. So here we need to see what is the number representation of that. So the number representation for that is actually uh, 1 and all zeros, and then for cat it will be uh, you know because this is second word in the vocab, so this will be 0 and this will be 1, right? And then the third word is set, right? So for set, this will be 0, this will be 0, and this will be 1, right? And then the next word is on, right? On. So again, all these will be 0 except this word, right? And then another the. So everything will be 0 except this one, right? And then mat, uh, here everything will be 0 except this word, right? So remember these matter, so they must be small, they must be small, they must be small, the mat, right? So this is one hot encoding for these 6 words. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right. So you can see this more or less become a diagonal matrix. Now you have seen neural network. Neural network cannot accept THE, but neural network can accept 1, 0, 0, 0, 0, 0. So we can have a neural network with 6 neuron at its input, and if you want to send there, then first neuron should be 1 and other 5 neurons should be 0. When you send mat, then first neuron, second neuron, third neuron, fourth neuron, fifth neuron should be 0. The sixth neuron should be 1. So the good thing is this one hot encoding actually gives us capability to convert words into numbers, and then those numbers can be used as an input to the neural network, right? Okay, so I end this here, the basic concept of one hot encoding. When I come back, I'll be discussing about how to code one hot encoding inside Keras. Thank you very much.